troubleshooting production issues as a developer. As it's already a bit late and we may be a bit tired, I'm trying to have it quick and funny. So we will do a live coding demo with all that it means, that things may not work, things may work properly. You never know, right? So this is our agenda for tonight. I'm gonna go through some introductions. Then I'll introduce you the problem. We will see live, and then we will jump straight into the code, right? After that, we will wrap up with some conclusions and questions and answers, should we have some, right? So let's start by introducing myself. My name is Carlos. I'm a Spanish Londoner, which means I'm from Spain and live in London. I'm enjoying London, but to be honest, I miss the beach, as you can see by the photo. I got my master's at Salamanca University in Spain, very nice city, should you want to go on holidays. And nowadays I work as a software engineer at MyDrive Solutions, which I will introduce later on. And I'm basically enjoying Cassandra since 2014, which is more or less when I joined MyDrive Solutions. If you want to know something more about me, you can follow me on Twitter. My handle is Calonso, and here you have my personal website. Right? About my company, I work in MyDrive Solutions. We are the world-leading driver profiling company. It was founded in 2010, and driver profiling company means that we use technology and data to try to understand how to improve driving behavior. Right? We are enjoying Cassandra there since 2012, more or less. And on a business note, we have recently been acquired by the Generali Group. And if you want to know more, this is the Twitter handle _MyDrive, the web. And if you fancy a nice atmosphere, nice job, and really interesting challenges, we are hiring, as pretty much everyone nowadays, I guess. In our web page, you can see our openings, right? Should you be interested. And well, let's jump onto the problem. The problem tonight is troubleshooting performance issues in production as a developer. Let's do it part by part. Troubleshooting performance issues. As pretty much everyone at some point faces performance issues with Cassandra, and you have to troubleshoot them. So we will face a real problem. Well, it's a simplified version of a real problem we had at MyDrive, right? The funny thing about this is that this happened in production, and if you want more information, it was on a Friday. And as a developer, because it's what I am, I'm a developer, and I'm gonna try to guide you through the steps I followed, more or less, to try to find the solution, right? A little bit more insight on what we will see. Well, this is the program we are going to see. Is again a simplified version of our production thing, right? We have trips from drivers. We import them into Cassandra as pretty much a time series, which is no doubt one of the best use cases for Cassandra, right? A little bit about the setup we are going to see tonight. We will see two environments. One is test, one is production, as I hope everyone at least does here. Each of them is a three nodes cluster, and all of them use same version of Cassandra, 1.2.9. And there you can see the create key space query. I use use to set up the key space. Pretty much everything standard, three nodes, replication factor of 2, and simple strategy. And this is the column family we are using. Very simple again, has driver ID as an integer, then a couple of timestamps which mark the start and end time of the trips, and a couple of locations saved as text, and then important thing, the primary key, the partition key is the driver ID, and they are clustered by end time, which means that all trips from the same driver are all together in this, right? The rest is pretty much boilerplate, right? And about the tools we are using, we code in Ruby, so the program we are going to see is Ruby. Hope that almost everyone knows Ruby. Hands up if anyone doesn't know Ruby. Sorry, guys. Well, hopefully Ruby is, I guess, is easy enough to be able to follow it. And apart from this, we will use Ruby Prof, which is one of the profilers we have in Ruby. And also Casanity, which is a Ruby gem that wraps the DataStax Cassandra driver that I am core contributor of, and it helps, among other things, to avoid spreading all the queries around your code as strings, right? So it brings a layer of sanity on top of Cassandra, is the formal definition. And no more. Let's jump straight into the code. Okay. So here we can see the import script, right? Let's try to follow it. We create a connection to Cassandra using the Casanity gem. Here we access the trips column family, as we saw, and as we are reading from a CSV, we are expecting like 10,000 records per run on this script, so it makes sense to prepare the statement, prepare the insert, that then here, while we are here we are parsing the CSV, and for each line we will just prepare a little bit the hash that the prepare statement is waiting. Just to let you know, Casanity prepares the insert specifying which fields is expecting, right? So in this case, driver ID, start time, end time, start location, and end location, which are exactly the same fields that come from the CSV. We are then throwing them asynchronously to Cassandra, so that is the driver that takes care on balancing the queries and distributing them across the whole cluster. And in the end, we just wait for all the inserts to finish, and and that's it. Just a good practice. I suppose all of you somehow monitor your timings, so we are using a combination of StatsD and Graphite to know how long are our jobs taking, right? So, well, we have as a developer has just finished the script. I'm gonna try it in test, right? CCM status shows that we have the test cluster here. All the 3 nodes are up, so just run import.rb. it's inserting 10,000 records while parsing them, and it has been pretty quickly. We can jump onto our graphite that I have it here. Is it readable, the code? Sorry, more or less. Yeah. Okay, so here in our graphite, this is the last execution. It took like 5 seconds to insert 10,000 records. We are monitoring our cluster with DataStax Op Center, very recommended as well, very interesting. We can see that the data is appearing right now here. Well, we have had this should rise to 90, something like this, but this takes a while sometimes. But we can see here in the response time that the average is like below 3 milliseconds per operation, which I think is pretty good performance. So, well, we are happy. We ask with our boss and our colleagues if we are ready to ship it, and we deploy the thing to production, right? Here I'm gonna simulate a production deploy in which I'm stopping the test environment, deploying the code, and running the production environment, right? Takes a little bit, starting right now, and hopefully we'll be ready soon. Yeah, perfect. So Op Center has to be restarted right now. Well, it will take a bit, but it will come. Okay, here we are with our cluster of 3 nodes. The data will come soon, and here we are gonna run the script a couple of times, right? As if we were users running the script, right? Okay, this should work exactly the same. 7, 8, 9, 10. Cold sweats. Well, as every developer, the first time you don't want to believe it, right? So you say, well, this is probably because, I don't know. Let's try again. 3, 4, 5, 6, 7, should be about to finish. 12. This is getting complicated. Where are the windows to jump through? Well, now it's funny, but this is happening in production, and our graphite monitor can actually tell us that there's something very wrong. We are having 3 times slower our code than it was expected. So, and it's happening in production, and the funny thing is that we have tested it in test, and everything should be exactly the same. So what the hell is going on here? Well, first thing that comes to a developer's mind is to, well, I have run this several times. It seems to be consistent. It's slow all the time. So, well, I don't know. I'm gonna try to profile the code to try to understand at least in which part of the code the time is being wasted, right? So, as I told you before, I will use Ruby Prof, right, which is the Ruby profiler, and to try to keep it quick, I have the recipe here with the profiling block, right? I don't know if this is the best practice in a talk, but wanted to make sure everything works. So basically what I do here is I'm going to indent this properly. So what I have done here is just wrap the important parts of the program inside a profiling block, right? So the profiler will, it's going to make the whole thing slower, and it's worth mentioning that you don't do it in your production code, right? But as this is a simplified version of the steps, I think for the sake of example, it's appropriate, right? So we will save and run the script again to try to have a little insight on if the problem is on the CSV parsing, on at some point in Cassandra or whatever, right? So this takes even longer because the profiler takes its time, of course, right? I think I can even drink water. Right, and here we have the massive output of the profiler. Bear in mind that we are under the pressure of the eyes of our boss continuously looking at the graphs, that they are not falling down, right? So yeah, we try to have a quick look of it to see where to begin, right? So 100% of the time is spent on global, which is the script, which is totally fine, is the whole execution. 51% of the time monitor mixing month synchronized, not very useful because we don't have any sentence like this in our code. Cassandra future get, this is something more familiar, 50% of the time. Cassandra, well, I think is Cassandra's fault, right? So, well, what I'm doing with Cassandra here is preparing an insert and inserting 10,000 rows. So, well, I don't know, but I think normally you guys try to simplify the problem, right, in a smaller script to try to understand line by line exactly what's going on there, right? So, once again, I have this simplified problem here, which also I'm not using here the Cassanity gem to wrap in the Cassandra driver because I want to go as bare bones, as bare metal as possible to try to isolate my problem, right? So, well, this is the header exactly the same as the original script. We need statsd to monitor our timings, and then simply connect to the cluster, open the key space, and then do a dummy insert execution. Again, this is something that we did on a new key space and column family we created in the production cluster, but obviously we are not inserting dummy data in our production database just for debugging purposes, right? So okay, we run this small script to see if it reproduces the problem, and then to try to understand it with fewer lines of code, right? So we run test. This should be is just one insert, is connect and insert, so it should be really quick, and this is taking already too long. So it's good because at least it's reproducing the problem, right? So let's go again to the same thing and try to profile the code. We are going to profile this smaller set of code, which is easier to understand. And if you look, we are not even using asynchronous features of Cassandra. We are just, in this case, using execute, which is asynchronous execution, which means, so line 21, I'm connecting to the cluster, line 23, opening, so it's using the key space, and these lines are just inserting a dummy record, right? This should be fast as a thunder. Given that Cassandra in Op Center was reporting to be being very quick, to be replying queries, you see here we were having peaks of 140, 150 queries per second, and it's writing in an average of below 3 milliseconds. So this should be really quick, but it is not being that quick, right? So let's run again with the profiler and see what we see. See if we can get something, right? Sorry for the long delay. Oh, where's the profiler? Cool. Sorry, I haven't saved it. Long wait again. Okay, cool. So let's come up here and let's try to see. Again, 100% of the time is spent executing the script. Makes sense. 99.88, again, something inside the Cassandra driver, not very useful for us. Here, Cassandra feature get. Well, that makes sense because given that we are using synchronous insertion, the Cassandra driver runs it as asynchronous and then waits synchronously for it, right? So it makes sense to be using features. This line is about Cassandra promise, which is not very helpful for us, not helpful either. Well, I'm beginning to get nervous because nothing's very helpful, and I have to tell something to my boss. Again, something about threads here, a mutex. Who cares about a mutex? And this is promising, at least. So, this line, can you see the line? Yeah, I guess you can. So this line says that the 99.37% of our time is going in cluster connect, so it's in connecting to the cluster. So, well, that makes sense because our statsd, our program, is telling us that we are being very slow. But then OpCenter is telling that Cassandra is responding very quick. So the problem is something in the middle of my program, the driver, and Cassandra, right? So this could be some connection problems, right? And well, at this point, if I'm honest with you, my first attempt was to try to read on Cassandra protocol to understand how the handshake was done and use a tool like Wireshark to capture the packets to see if everything was going, but to see what was happening there. But I thought there has to be a better way. I have come to loads of meetups, loads of summits, and everyone says that Cassandra is simple, resilient, and fast, and this is going too complicated. So, well, I had the brilliant idea of enabling logging in the driver, because, well, the driver is who connects to Cassandra, and maybe it could give me some more insight on what the hell is doing, right? So I require logger, which is a Ruby library for logging. I create a logger object, connect it to a standard output because I want it to print to the standard output, and I tell them to have a debug level, right? And I add it to the configuration. Okay, and cross fingers to get some idea on what's going wrong there. And that's good because, well, we see loads of output, and at some point the thing stops, right? It has created several connections here. Okay, and finished. So, well, let's see first of all which was the line about to appear, which was this one, and it's really revealing, and that's when every developer knows why they love their jobs, because they, yeah, got it. So it's actually saying, well, within 10 seconds could not connect to, well, this IP, which I guess is one IP of the ring, and because it's refusing the connection. Actually, these 10 seconds is really revealing, because if we can back to our graphite, and we subtract 15 minus 5 is exactly the 10 seconds overhead, the 10 seconds extra we were having from production to our test environment, right? So yeah, okay, at least we have a reason. But now, why is the driver trying to connect to that node when, if I ask it to describe the ring, it tells me that it's composed of 3 nodes and all of them are these addresses, and the address I'm seeing was something like 93.184.216.34. How this is possible? Well, then reading a little bit on the documentation, I got that the driver takes the list of nodes to connect to from the system peers table from the node it is using as a coordinator, right? So if I connect to that node and I tell him to show me the peers, we can see here exactly that node that is somehow corrupt and is breaking our performance. Okay, that's great, but why is this happening, right? So ask Google. So Cassandra, wrong address, system peers. You see that I have looked it just before coming, and revealing the first result is a Cassandra bug, which tells system peers table not updated after the commissioning nodes in Cassandra 2.0. Well, this is not good because we are on 1.2.9, but it could be reproduced in 1.2.9 as well, right? Well, the bug is that, well, at some point our ring was 4 or 5 or more nodes, and while the commissioning them, at some point this bug had effect, and then the table system peers got this wrong address stuck in there, right? Reading through possible solutions asks us just to delete the wrong record, so let's go for it. Delete from system peers where peer equals this bad guy here. Okay, done. Let's check it. Perfect. And then let's run our import script, well, our test again. Wow, this is great. And let's run our import script again. 2, 3, 4, 5, 6. Damn it. Why? This shouldn't be long. That. Okay. Any ideas? Well, could be, but it's because the profiler is very slow. Right? So if I comment the profiling lines, and run it again, count 1, 2, 3, 4, 5, please finish. More or less, here we are, right? And our graphite dashboard, well, it will, yeah, there you go. Here we are, right? So, well, this is the process that a developer takes to fix something in production after a lot of stress and heartbeats and all this stuff that you probably already know. So, yeah, let's just after this wrap up with some conclusions. First conclusion is measure everything, because in this case metrics and monitoring lets us know that we were facing an unexpected performance issue. Second, and even more important, is keep calm and read to the end, because on our first profiling report I could have spotted that the issue was on Cluster Connect, but due to the eagerness to find a solution, due to the pressure, due to whatever, I made a wrong assumption and went straight to build that small script to try to understand and then profile, and then, well, this was about 2 days. It wasn't that quick, right? It took us about 2 days. Well, actually, we had to disable the feature in production, right, and do it in a separate key space and column family that the error was happening until we found the error, right? Also, thank the community for the great tools we have, like Cassandra, that even that sometimes is some we had bad times with it. It's a really nice tool. Thanks Apache and DataStax. Thanks for Stats, the Graphite, and Ruby Prof, and special thanks to Patrick McFadden, which is a DataStax guy that we involved in this process since almost the very beginning in a Cassandra London day and in Stack Overflow. These guys are really helpful, so if you find yourself in trouble, make sure you contact one of them. And thank you guys for listening. Hope you enjoyed, and well, that's it. If you have if you have any questions.